All right, here we go. This is like the last of the uber sections of all this nasty fraction business. And I shouldn't say nasty because really what I've been telling you is that fractions are our friends. So get out your notes and let's conquer this big mountain that we have in front of us right now. Okay. So I'm calling this section C because there's so much kind of power loaded in here. All right. So 2, 6C, and it's adding and subtracting rational numbers. And you're saying to yourself, for goodness sakes, isn't this what we've been doing all along? But we've been taking baby steps. And here we're getting to the big, giant leap. Ready? So here we go. Our learning target today. And again, it's going to sound a lot like what we've been doing the whole time here. We're adding and we're subtracting rational numbers. Okay. But here's what's different today. So let me get the rest of this written down. Adding and subtracting rationals. Hang on. Remember that rational numbers could be written as mixed numbers. They could be written as fractions. They can be written as decimals that terminate or decimals that repeat. So what's different today is that we're going to throw in an awful lot of positive and negatives. Okay. So I'm putting that in parentheses there just to get you thinking about that. We spend a lot of chapter 1 dealing with integers, which were just the whole numbers, 0 and the negative whole numbers. So now we're going to get into the last of the complicated stuff here. All right, decimals. Decimals, I think, are probably a little more straightforward and a little easier to deal with. So let's look at this example. Okay, and jot this one down. Negative 14.2 minus a negative 3.7. Now, when you see you're subtracting a negative, we've emphasized that subtracting is really adding the opposite. So I need you to think that this is really negative 14 and 2/10. Change this to adding and change this to the opposite of negative 3 and 7/10, which would be the positive 3 and 7/10. Oh, now this isn't bad. Okay, so I have these two. Here's the deal though. This guy's negative, this guy's positive. So depending on how you like to think of this, whether you think of it as kind of like a tug of war on the number line where you're going to go backwards 14 units and then come forward 3.7, you know that you're going to land in negative land. Or maybe you like to think of money, where you spent 14.2 and then you add 3.7 and you're still in the hole. Some people like the elevator analogy. You go down this many and come up this many. You're still down below. Or I always like to think of it as kind of like two teams. You put the negative team on one side, put the positive team on the other. They wipe each other out or neutralize each other, but the negative team has more. So they win the battle, so to speak. Okay, so I know the sign of my answer. Now, because my signs were different, you need to find the difference of these two numbers. So off to the side, you take their absolute values, the 14 and 2/10, the 3 and 7/10, line them up and find the difference. Okay, decimal point in my answer. I have to do a little bit of borrowing here. And you should get 10 and 5/10. It has to be negative. Okay, 10 and 5/10. Boom. There you go. Okay, so with decimals, figure out the sign and then whether you add the absolute values or subtract them. Okay. All right. Well, what about fractions? Same deal. Okay. It's just that we've got all these different levels we have to deal with. So let's take a look at this particular one. 4/7 minus 9/14. Okay. 4/7 minus 9/14. Well, the first thing I need to do is get a common denominator. So luckily, 7ths and 14ths, this isn't too bad. I'm going to rewrite this guy as 8/14 and rewrite this guy as 9/14. Okay. Once you have a common denominator, really, now you can just look at what's going on in the numerators and do that math. So really, I'm asking you to figure out what 8 minus 9 is, and then I'm going to put that answer in the numerator over 14ths. Well, 8 minus 9 is the same as 8 plus negative 9, or if you can just do that in your head, realizing you're going to end up in negative land, you get negative 1. There we go. Boom. Done. Now we get to the icky stuff, the mixed numbers, okay? Let's look at this one. Negative 4 1/3, negative 2 1/3. Well, there are a couple of ways to go about this. One way is to say, look, I already have these common denominators in the fraction part. So one way you could look at this is say, well, negative 4 1/3 plus a negative 2 1/3. I want to think of my subtraction as addition. When I look at this, I say, well, guess what? If this is negative and I'm adding more negatives, my final answer is going to be negative, and all I have to do is add the absolute values together. Okay, so take the 4 1/3 and the 2 1/3 and simply add those together. Common denominator, that's good. Add the fractions, add the whole numbers. There you go. Knowing that my final answer is negative. Okay, or you could think of it this way. Some people would rather just change everything into an improper fraction and go from there. So let's look at this. Okay, I'm still going to take this first step where I'm thinking of this as negative 4 1/3 and adding negative 2 1/3. But then I'm going to change these both into improper fractions. 4 times 3 plus 1 more is 13 thirds. And it's negative, and I'm going to put the negative sign up there in the numerator. Change 2 1/3 into an improper fraction. 2 times 3 plus 1 more, 6, 7. And put the negative sign up here. Now that I have thirds, I know my answer is going to be in thirds, and it just becomes a problem of adding the numerators. Negative 13 plus negative 7 is negative 20. Okay, now really in algebra, I'm kind of okay with you leaving your answer this way as long as it's simplified, meaning there's no common factors. I'm okay with negative 20 thirds, but you can also turn it back into this, which would be negative 6 2/3. I would accept either answer. Okay? All right, one last mixed number one. Okay? Just so you kind of see the of it all. You have negative 6 1/2 plus 1 7/8. Now, as I'm looking at this and I'm doing some analyzing before I even dive in, negative 6 and something plus almost 2. If you think about this, okay, going backward 6, coming forward 2, I'm going to get a negative answer. That's where I land. So when I have different signs, now I have to find the difference between these two. So really, well, or maybe this would be a good one to change into improper fractions and go from there. And then you just have to look at the numerators and go from there. So let's do that. I think we'll take that route. Negative 6 1/2. Okay. If I first of all leave this as halves and I say 6 times 2 plus 1 more, 12, 13, and put the negative sign up there. Okay. This is 1 7/8. If I change that into an improper fraction in eighths, 1 times 8 plus 7 more, 15. Okay, I can't quite do this yet because I don't have a common denominator. So let's change this negative 13 halves into eighths. Times 4, times 4. 13 times 4 is 52. I know that off the top of my head because I think of a deck of cards. They're 13 in a suit, 4 suits, 52. This is negative. Okay, so I have negative 52 eighths and a plus 15 eighths. Maybe this is easier for you to deal with because now you can just come off to the side and think this is like negative 52 plus 15. That might be easier to say, I just get negative and I find the difference of these two because I know my answer is going to be negative. I come off to the side and say different signs, find the difference. 37. I get negative 37. All right, so this equals negative 37/8. Okay, so I'm going to come up here and say negative 37/8. Now I know you're so trained, so maybe it's going to be easier for you to change this back into a mixed number. So you ask yourself, how many times can 8 go into 37? And that'd be a 4 because that's 32. And there'd be 5 more. But this whole answer is negative. Okay, now really, I would accept either one of these answers, the improper fraction or the mixed number. Okay, but now we've added this level of complexity, which is watching the signs. So your assignment is going to be in Schoology. I want you to look there. It's in your packet, but I want you to look there for the specific problems and pages in your packet. All right? And as always, may the force be with you. Good luck.